This video will focus on the target. I can apply the law of conservation of mass. So most of you have heard of the conservation of mass and probably already have it memorized. Mass stays the same in a chemical and physical change if nothing is added or lost, is what you've learned before to a song, some of you. For us, it's pretty much that. In any physical change or chemical change, mass is neither created or destroyed. It's just conserved, or it rearranges, right? Reactants become products. Bonds are broken, but the element is still there. We don't destroy it. A couple things now that you are juniors in relation to this that you need to be aware. Number one, it is during a chemical or physical process. So if we are dealing with a nuclear process, the conservation of mass does not apply. Remember that this is a law, and a law is only under specific conditions. So the law of conservation of mass specifies the conditions of chemical and physical. Okay, so it's not that the conservation of mass is disproven in a nuclear reaction, it's that it's not part of the conditions of the law. So if we are dealing with a nuclear change, this law does not apply because it's not part of the conditions. The other really common misconception for people is that somehow when you make a gas, okay, so if you're dealing with a reactant to becoming product, a lot of times you might start with like 10 grams of material and end with 8. And the reason that happens is because you produce a gas. If you produce a gas, the gas leaves the balance and you cannot mass it anymore, right? You've made gas. Specifically, you can now say, oh, if I started with 10 and I have 8, I made 2 grams of gas. Again, that's not disproving the law. That is within the confines of this law. Nothing is created or destroyed. It just changes the bonds and the rearrangement. It's just something to keep track of. A lot of people like to say like, oh, I went from 10 to 8. Did we disprove the law? And sometimes based on your 8th grade definition, people say, well, no, because the definition says if nothing is added or lost. And I would say, no, that's not it. Mass was there before, mass is there after. You just didn't capture it, right? So you need to be specific when you talk about that so is lost, because it's not, it seems like a very big misnomer for people when you use the word lost. Like, what does it mean to lose it? So be aware. 11th grade definition versus 8th grade definition, nothing is lost, even if it becomes a gas. It's just a question of you having proper laboratory technique to capture it. And then the loss of mass in a nuclear change is outside the confines of the actual law. Okay, that's it for the concept. Have a nice night.